Hello, Christopher.
Hi, Agata.
I would like to discuss with you about a very important topic now because in the serial production, we also have to assure the quality with the suppliers on the daily basis, I would say. How you are doing this at Charge Cars?
So at Charge Cars, we use an incoming goods control plan. So depending on the type of components, as I've mentioned in previous videos, if it's an ASIL requirement, functional safety critical components, they will undergo 100% inspection, or depending on the level of control of the suppliers, we will sample check based on the risk and probability of capability as well. So statistically, what is the likelihood of components being out of specification? Regardless of that, there's still a level of conformity of production which we must adhere to, especially when it comes to launching the vehicle into mass production. So we have to prove ourselves to the regulation bodies. Um, so we would do that. We look at functional parts and cosmetic parts. So we will again sample parts based on the incoming goods. If we've ever had any quality concerns during the phases of development that we're currently in for the 67. After that, we can increase and decrease, but there is an element of firewall protection that we do with suppliers. So at the start of production, or at least in the first 3 months, I will implement the same methodology that I've had through the Japanese um, OEM that I worked for. I'm going to introduce something called Shocky Redo, which is basically 3 months firewall where suppliers need to put in a level of inspection. Once they are training and detecting all of the problems that they find with their own internal processes, the results of that incoming inspection from them will then allow us to take the inspections or reduce the level of inspection for us. Eventually, we want to get to a point where it's process maturity, because the biggest risk is when you go to launch and the supplier, in some cases, might be at full capacity. So they are producing far more parts than they usually would, especially in the trial phases and development. They might only do 10 maximum over the space of the year. When you increase your volume, even for a micro manufacturer, that's still risk, because some of our suppliers aren't necessarily used to those volumes. So there has to be a level of firewall overcheck. This firewall needs to be separate from the production processes. Same in Charge. When we receive incoming goods, we have a separate area for incoming parts where production cannot see them, so they can't touch them. They're locked away. They're checked first. They're put on a quarantine status until they've been QC cleared. So that's how we typically do it on a day-to-day basis.
Hmm. Okay, you're producing an electric car. Um, so definitely you have a lot of components which are called pass-through. Uh, can you explain how to handle such components? What you are doing? Because let me just maybe emphasize what pass-through means. So pass-through, these are those components or characteristics which are simply not controlled when they are coming to our facility. Yes, they need to be controlled. We shall ensure their conformance to the requirements at the place of the manufacturer. Yes, so definitely this is very frequent in electronic. Yes, how is it done at your organization?
Well, from a structure perspective, the first thing we do is we look at the design failure mode effect analysis. So we look at the probability of the failure modes that can exist and may exist as in cause and effect to the final customer. So if, for example, a semiconductor is not soldered to the circuit board correctly, and you have a defect such as tombstoning, then the function of the part shouldn't work properly. Things like solder balls in that world, when we talk about a loose piece of solder that can fall anywhere randomly, so it's really important that the supplier knows about these type of defects, and they have a robust manufacturing process and detection method. In some cases, we work with suppliers that have never worked with an end-of-line facility, or that don't use automatic optical inspection or ICT testing. It depends on the type of component and the failure modes that can exist. Um, my view is not if it will fail, but when. Eventually, every part will fail at some point. That's why we have warranty. That's why we have service parts. That's why cars get replacement parts due to wear and tear. That's normal. But the thing that we have to prevent is pass through problems into obviously us as an OEM, because that can stop us, and even more so in the warranty, because the warranty costs are much higher. The vehicle, when it's in the field with the customer, could be anywhere in the world. It could be in Dubai, it could be in America. And for Charge, our dealership structure is different to most OEMs. We would have to fly out there and visit the vehicle, look at the problem, diagnose it, probably at the customer's garage or drive, wherever they keep the car. All of these things have to be mitigated where possible. If the supplier's process cannot detect it and they don't have sufficient control, and we are able to detect it at Charge, we will put it on our incoming goods list of checks. If we're not able to detect it, the risk is much greater. But we should design a vehicle and components where we don't have anything pass through to the final customer. There needs to be like a fail safe, a failure mode, a sensor that can detect if something isn't functioning correctly. This is why vehicles have warning lights. So, for example, in battery manufacturing, we have lots of thermistors, we have lots of thermocouples that can check for temperature differences and shifts. We have warnings, a part of regulation that will say on the dash that if there's any problems with that internal component, if there's any issue, it will tell the driver stop, stop the car, turn it off, that sort of thing. So
Hmm. Okay, so with pass through, we may say that error proofing at the point of the manufacturer might be very essential, or pookayoke, and even at your plant. Yes, are you applying such solutions?
yeah, so the first thing is when we nominate a supplier, the processes aren't stable. Ideally, you want to pick a supplier that knows what they're doing. They absolutely understand the product, like seatbelt suppliers or airbag suppliers. We know some of the really big names in the industry, but we mustn't be complacent. Just because they're an expert in that product doesn't mean they can't be failure modes or problems. I've had issues in the past in previous projects and models that I've worked on where the suppliers are considered to be the expert, but they don't put basic error proofing in there, pookayoke, as the Japanese call it, mistake proof. They don't in some cases they don't understand the different types of pokeyokes. One is the one where it can't be passed on to the next process, and the other one is an alarm system. But alarm systems can be ignored. So my preference is to work with suppliers, my engineers, to work directly with them, to teach them, to develop them, to show them there are simple, cost-effective solutions which are minimal to the process. You don't need a huge robot arm to pick up a part and throw it away and lock it away and burn it. You don't need to do that. I think there are some very simple design pokeyoke you can put in place, and there's some very simple process ones where a part can't go through a profile gauge, for example. It will not pass on a conveyor. Things like that can be done. So typically, based on my background experience, I come from Japanese mentality of manufacturing. I push that into the supply chain, even in working for a UK based company. So
Okay, great. Thank you very much, Christopher. This was really long, long discussion. However, let's stop in this moment, and I invite you to another episode. Next time, I would like to talk with you about the development of the supplier, why we shall develop our suppliers. Thank you.